Hi again. So today we're going to extend our parent trig graphs to some more interesting trig graphs, I guess, for lack of a better word. Now, when we look at an equation of a trig graph, we can start with our basic parent, sine x. Every trig graph actually has three features that we need to be able to talk about. The first is amplitude. Amplitude is otherwise thought of as the height of the graph. If you want to make a connection to music, when you plug in a stereo, you plug it into an amplifier. So sound waves are actually sine graphs, sine waves. And so the louder the music, the taller the graph, the bigger the amplitude, amplified. In our equation, if we have an equation in the form y equals a sine bx, the coefficient a represents the amplitude. We actually say amplitude is the absolute value of a because we can't have negative heights. Okay. The other key feature is what we call frequency. And frequency is how many cycles, I should say how many complete cycles of the parent we see between 0 and 2 pi. Frequency in our formula, or in our general equation, is the absolute value of b. So in our parent sine graph, my amplitude or height is 1, my frequency is 1. I see one complete cycle from 0 to 2 pi. The last key feature, the last real vocab word today, is what we call period of a graph. This is a formula you need to know. They ask it all the time. The period formula is 2 pi over the frequency, over the absolute value of b. It's another formula you'll want to write down. And notice we use frequency within our period formula. So period is how long in radians before our first cycle ends. So frequency is always talking about the 0 to 2 pi window. Period tells us how wide our graph is, essentially, how long before the first cycle of our sine or cosine curve ends. So for the first part of the lesson, you really just need to be able to look at different equations and recognize amplitude, frequency, period. So if I gave you something like this, I might give you y equals negative 2 cosine 1/2 x. Worst case scenario, you've got a lot of stuff going on. Well, we need to be able to list the amplitude, the frequency, and the period. Okay, well, here, amplitude is what I wrote up here, the absolute value of a. So a is negative 2. The absolute value of negative 2 is 2. There's no such thing as a negative height. If you say that amplitude is negative 2, you won't get any credit. It makes us crazy. No such thing as negative height. Amplitude is always positive. Math being consistent, you know from all of our other parent graph transformations that that negative is a reflection over the x-axis. And we'll do that when we graph them in a minute. Frequency. Frequency, defined above, is the absolute value of b. So the frequency of this graph is the absolute value of 1/2, which is 1/2. So that means I'm only going to see half of my complete cosine wave from 0 to 2 pi. Okay? Which means it takes a long time for me to completely see a graph, which means my period. Period, the formula we really need to know, is 2 pi over the absolute value of b. Well, 2 pi divided by 1/2 is 2 pi times 2, or 4 pi. So it takes a length of 4 pi on my x-axis before I see one complete cycle of cosine. A wide period with a big frequency, or a small frequency. Okay, so that's the first part of the lesson. The second part of the lesson is being able to graph some of these things. And for the first day, we don't mix it up too much. Tomorrow we'll do more practice. So I might ask you to graph this y equals negative cosine 1/2 x in pieces. So let's talk about amplitude first, and all the work I want you to show me. So let's graph y equals, let's just do 2 cosine x. Okay. Here's what I want you to be able to do. I want you to recognize that the parent is cosine x. And I want you to be able to graph what I call a quick sketch. And the quick sketch comes from yesterday's lesson, where there are those 5 major points that you need to know. Cosine always starts up at 1, the cosine of 0 is 1, and ends at 1. It valleys to -1 halfway, and has the zeros in between. So cosine's quick sketch, I always call it, looks like that U, with 5 major quick sketch points. Now, looking at the equation I need to graph, amplitude or height is 2. So instead of starting at 1, my graph is going to start at 2. And instead of dipping to -1, it'll dip to -2. So I label my quick sketch to help me transfer it to good graph paper. Here my frequency, and we need to list these by the way, amp is 2, frequency is 1. So I'm going to see this complete cycle, one complete cycle from 0 to 2 pi. So it ends at 2 pi. My period is 2 pi divided by frequency, or 2 pi. Again, your period is the value, the place on your x-axis where your first cycle ends. So you draw your quick sketch, you label amplitude, frequency, and period, and then you transfer it to the good graph paper. So this graph starts at 0, 2. It ends at 2 pi, 2. Halfway between the 2 peaks is -2, so at pi, -2 is my valley. And then we have the 2 zeros exactly halfway between there. And you always connect it with a nice smooth curve. Now real quickly, to make a connection to our whole transformations unit with our other parent graphs, the parent cosine graph, remember, looks like this. And with our x squareds and our cubics and square root parents, we talked about how a number out front was a dilation, and it still is. Math is consistent. We just have special vocab when we talk about trig. But this has certainly been dilated. This point started out 2 blocks away from the x-axis. 2 times 2 stretched to 4. 0 stays 0. This 2 blocks away stretched to 4 blocks away. 0 stays 0. And same thing here. So certainly make those connections, because math is indeed consistent between dilations and amplitude with our trig graphs. Okay, now let's graph. I'm just going to stick with cosine because that's what I used with the first example. Let's graph negative cosine 1/2 x. Okay. Again, my parent is cosine. My parent cosine graph looks something like that, with the 5 major points. Now, this negative out front means it's been reflected over the x-axis. So really, I'm going to end up graphing this guy. It's truly my parent now. The amplitude is 1, not -1. Height is 1. The negative is the reflection. So it still peaks at 1 and valleys at -1. My frequency is 1/2. That means that I'm only going to see half of this curve from 0 to 2 pi. So my 2 pi point is going to be right there. I'm only looking at half of my curve in 2 pi. Frequency means how much of my curve do I see from 0 to 2 pi. Period is 2 pi divided by frequency. We saw earlier that that's 4 pi. Period is always the end point of my first cycle. So this graph would stretch to 4 pi. Now to transfer this to the graph paper, I don't have 4 pi, so I'm actually only going to show this first half of the graph. It starts at 0, -1. It ends at 2 pi, +1. And halfway between every peak and valley is a 0. And these are always curves, even if it looks like you could connect with a straight line. Make it a curve to show that it is a piece of cosine. And that's it. Again, if you wanted to compare this with your parent graph of cosine, there's your parent. Its height is the same. but it's been reflected over x. So if I reflected it right away, it would have ended up like this. But then I needed to stretch it. I have this frequency, which means it's a slower song. Frequency is smaller. So I have to stretch my horizontal distance out, which is a new thing for transformations. We never dealt with the horizontal stretches before, and we only do that with our trig graphs. All right, and really that's all I want you to do for your video, and we'll talk much more about this in class tomorrow. Have a great night.